So we're starting a new chapter today. This is going to be a kind of a new topic, but there is some overlap from some things you already know. And luckily today is one of those days of there's quite a bit of overlap. Okay, so what this chapter is on is what we call conic sections. And there are 4 different shapes or sections, cross sections that you can do to a cone. And all the different shapes that could be created are called the conic sections. So here's a kind of a quickie image I got off Google that if you were to take a cross section of a cone, now this is what we call a double napped cone. They're one on top of the other. With their vertices touching. But if you just look at, let's start with this is probably the most basic scenario. If you were to take a plane and you were to slice it through the cone, it would create a circle right here. And so a circle is what we would call a conic section. Now, if you took your plane and you went through it at an angle rather than parallel to your base, that circle would become elongated, and now it's an ellipse. So an ellipse is another conic section. If you were to take a plane and have it pass through the side and down through the base, instead of from side to side like these were, if it goes down through the base, all right, well, that gets wider and wider and wider as that base gets longer. And so that actually creates a parabola. So there's another conic section. Now, there's another scenario, and this is why we need the double napped cone. If you do it like that and you drop a plane through the double napped cone parallel to their heights, so not at an angle, but straight through it, then what you get is what we call a hyperbola. And a hyperbola is something that has 2 branches to it. You have one that's up here and you have one down here. And what it's actually kind of using is this side of the parabola is, I'm sorry, the side of the cone is sort of like an asymptote for how wide that hyperbola gets. All right, so those are the 4 different scenarios that can be created. Now, conic sections, this is a visual of what conic sections are. You could also look at conic sections as a set of points, and there's some sort of a definition. And so we're going to look at all 4 of these scenarios. Today, we're going to do a circle and a parabola, because those are the 2 that you probably know the most about. We're going to get those out of the way early, and then we'll talk about the ellipse and the hyperbola over the next few days. Now, we've actually already talked about circles back in the beginning of this course, and so this is going to be kind of just a review as we approach that final. It's not too far away that some of this review stuff that gets popped in is kind of good for us. We'll talk about, get kind of a little bit more advanced, do some applications, and then we'll talk about some parabolas. Now, first of all, with a circle, there actually is a definition of a circle, and I know that you've known what a circle is since preschool, so it's hard to think what's a definition of it. Well, it's really the set of all points in a plane that are equidistant to a point called the center. Okay, so I have already plotted a point here for us, and that's going to be our center. And now I'm going to pick a number, I don't know, some number. We did this in class with a string, so this will be a little bit different scenario for you, but let's say you pick a 20 centimeters. And so I want to plot all the points that are 20 centimeters away from this center point. So I could put one out here that's 20 centimeters. I could go up 20 centimeters. I could go down. I could go left. I could go anywhere in between as long as I'm 20 centimeters away. And if you start doing this, and all the points that would be created would suddenly create this circle that would have a radius of 20 centimeters. Okay, so there's your radius. That radius is that common distance that you use. All right, so that's how you create a circle. Now, the things that we've already talked about are mostly just like the equation and being able to graph it. So here's your basic scenario. This is the equation of a circle. It sets up like this, where H and K create the center. This is with the X, so it tells you how far you're going left and right. This is with the Y, so it tells you how far you're going up and down. You're inside parentheses, so you'll always do the opposite of what the sign is. So if it's an x minus h, then the center is going to be a positive h. And a y minus k, we'd have a y value of a positive k. And it equals r squared, and the radius of your circle is just r. So you would always take your radius value and square it. Okay, so let's try going both ways. In this first example, basically I'm giving you the equation. You should recognize that the center is going to be the ordered pair 4, because it's a minus 4. Remember, it's always going to do the opposite. And since the y value has a plus 2, it's actually going to be a negative 2. That's going to be the center of our circle. I'd plot it at 4, negative 2 right here. And then the equation equals 9. Remember, 9 is equal to r squared, so then the radius would be 3. So to graph this, I would just go left and right 3, up and down 3, and then try to do a good job of making that look like a nice round circle, not like a rhombus, or don't get it flat, make it a nice round circle. Okay, so that's probably the easiest situation right there. Let's look at some other stuff. Could you write the equation of a circle that goes through the point 10, 2, and whose center is the origin? Now, there's different ways to do this, but first of all, let's make sure that this makes sense what's going on. The center is going to be at the origin right here, but then there's this point on the circle over 10 up to somewhere here that lies on the circle. And I'm supposed to write, ooh, that's a bad circle. Okay, so I'm supposed to write the equation of that circle. Well, I feel like the easy part is that the center is the origin. So the center is going to be 0, 0. That makes your h and k 0. So that's just going to be an x squared plus a y squared. I don't even need the parentheses. But what they didn't tell me was what the radius is. So that's what I've got to work on. I've got to work on finding the radius. That would be this right here. So now there's a couple ways to do this. You could do the distance formula between 0, 0 and 10, 2. 0, 0, 10, 2. All right, so then you'd have x minus x, so 10 minus 0 squared plus 2 minus 0 squared. So then you end up with the square root of, that's a 100 plus a 4, so a square root of 104. Now I could go to a decimal, but I'm not going to mess with it, and you'll see why in a second. If the distance between those two is 104, you basically just found the radius measurement. And if you're going to take that radius measurement and square it to put into your equation, then there's no reason to mess with getting a decimal, because if you square it, then you're back to the 104. And so this is the equation of your circle. Now, another thing that you could have done, because the equation itself is the set of all the points on the circle should work in that equation. And since we knew what the center was, I could have just plugged the 10 and the 2 in for the x and the y. So this is just another option, just so you kind of understand. If you plug the 10 in for the x and the 2 in for the y, and that's supposed to equal your radius squared, you can see there's your 104 equals r squared again. And since you do want it to be an r squared, you would just put a 104 there. So either one of those options would work for you. If you recall back when we last did this, I made it even trickier than this, and we are going to definitely have some that are trickier than what I just did there. What if I didn't tell you what the center was? And I think what we have done before is I've given you a problem where I gave you the endpoints of a diameter. So it was something like, you don't need to put this in your notes, but if I gave you the endpoints of the diameter, well, if I don't tell you the center, you do know that that would be the midpoint between those two. So remember doing that, you'd find the midpoint, and then once you had the midpoint, then you could do the distance formula here. I feel like if the center is not at 0, 0, I probably wouldn't do this method here. That just worked out really nice because the center was at 0, 0, but whatever works for you. All right, so just recognizing all those characteristics of a circle. I'm going to jump in then and look at some parabolas. All right, so we already know the definition of parabola. We've spent lots of time on parabolas, but this is a different way to think about a parabola. So just like the circle is the set of all points equidistant from the center, a parabola has a definition similar to that. It says the parabola is the set of all points in a plane that are equidistant from a point called the focus. It's right here. I use an F for the focus. So let's write the word focus there. So they're equidistant between the focus and a line called the directrix. These are new things. So what we're going to talk about parabolas is going to be new for us here. So this line down here is the directrix, and then I have a point here, the focus. Now, every one of the points that fall on this parabola, P, for example, if you were to measure, and you'd always go perpendicular because that's the shortest distance to that line. If you were to measure that and then measure to the focus, those two would always be the same. I could pick another point, maybe way up here. And if I were to measure to the focus and measure down to the directrix, those two measurements would be the same. Now, they're not the same as the two over here, but they are the same individually. Okay, so I could do that all over the place. Don't do this to yours. It's going to be a mess. If I went here, I went to the directrix, to the focus. That's the same as that. Now, with all of that being said, what I'm really interested in is if of all those points, I'm going to, oh, is it going to let me erase? Yeah, I'm going to erase this to kind of clean it up a little bit. What I'm really interested in is the vertex of the parabola. The vertex of the parabola is right here. And if I measure to the directrix and measure to the focus, remember those two should be the same. That might be worth putting in your notes because the distance from the vertex to the focus and the vertex to the directrix is always going to be equal. That's going to be important. And in fact, it actually has a letter that we assign to it. The distance between the vertex and the focus we call P. Oh, that is not what I meant to do. That's a little p, not like point p, but just it's a little p. I don't know why we use a p, but that is. The distance between the vertex and the focus is defined as p. Now, it happens to be the same as the distance from the vertex to the directrix. All right, so let's get some of this terminology in here. The vertex, okay, is equidistant. I'm going to make this bigger so we can see it a little bit better, and I have a little bit more room to write. The vertex is equidistant between the focus and the directrix. It falls right in the middle of them. All right, the focus is always going to be on the axis of symmetry. Now, we haven't talked a lot about the axis of symmetry, not the axis of symmetry. We can talk a little bit about symmetry, but you know that a parabola is going to have a nice axis of symmetry that cuts it right in half. It's going to go through the vertex, but it's also going to go through that focus right there, always. And it will always be, the focus will always be inside of the parabola. It's kind of in the cup of that parabola. All right, now the directrix. The directrix is down here below there. So the directrix is going to be perpendicular to your axis of symmetry. And it will always be outside of your parabola. It will never touch the parabola. Now, it is going to be a line, so you're always going to write the equation of it like a y equals or an x equals. If it's horizontal, it's a y equals. If it's vertical, it's an x equals. All right, now the only way that it's going to be vertical is if your parabola gets turned sideways. And we'll talk about that in a little bit. All right, so now one other thing, like that p value that I was talking about, the distance between the vertex and the focus, what's the point? Well, it is what dictates the width of your parabola. So it is determined by the p value. Oh, sorry, that is not what I was supposed to put there. It is determined by the distance between the focus and the vertex, which we have said is designated as P. Now, we already know from earlier that the width of a parabola is dictated by the A value in an equation. So there's got to be some relationship between this A and the P. They're not the same thing, but the relationship looks like this. A is equal to 1 over 4P. Another way, you could rearrange that into another equation. You could say P is equal to 1 over 4A. Which one of those you use just depends on what's given to you and what you're trying to find. But those are your relationships between the A and the P. Both of those dictate how wide that parabola is. They just do it differently. Okay, so let's try one. Now, you've graphed parabolas left and right. Okay, let me say that again. You've graphed parabolas a lot. Now, what I'm going to do is show you some of the new things about a parabola that we have. If you look at this one, can you look at this equation and see what looks wrong with it? All right, it is an x equals, and then the y is in here. Normally, it's the other way around. All right, so if it's the other way around, we know that your parabola is going to be like opening upward, or maybe it could be opening downward if the a was negative. So if you have an x equals instead of a y equals, instead your parabola is going to open left or it's going to open to the right. So it's going to be a sideways parabola. So in this case, since it's an x equals, it's sideways, not up and down. Now, that's going to mess everything up because your vertex that we're so used to being H and K, which is like here's your H and your K, remember, your left and right, up and down. But see how this 2, it's now grouped with the Y? So that's really your K, and this is your H. So these get swapped. This is going to tell you how much you're moving up and down because it's with the Y. This is going to tell you how much you're moving left and right to get to your vertex. Now, this is inside the parentheses, so you still do the opposite. This is not, so we'll do what it says. So the vertex on this one would be left and right. Think left and right is going to be out here now. So I'm going to have to go left 1. And then this is going to be my up and down. I'm going to do the opposite. So I'm going to go up 2. So the vertex is -1, 2. It's really easy to forget to do all the swapping of everything on these sideways parabolas. So pay attention to that. I'm going to go ahead and plot my vertex at -1, 2. Now, because this is a sideways parabola, if I were to cut this thing in half, whether it was the left one or the right one, if I cut it in half, it's going to be a horizontal line. So the axis of symmetry is going to go right through the vertex, and it's going to be a horizontal line. Horizontal lines are going to be y equals. And so if this was, and you don't necessarily have to graph the axis of symmetry, but it would go right through here. So that'd be a y equals 2. Now, I also want to find the focus and the directrix. So before I get too deep into this, I'm going to go ahead and graph this. And to graph this thing, I'm kind of doing the same thing I did before. I don't get caught up on, and when I say before, I mean like in chapter 1 when we were doing this. What I mean is that I'm not going to get caught up in the X and Y table. I'm not going to do that. We've done enough parabolas that we know what this 3 does. It has this stretch to it. But since everything is flip-flopped, what I do is I take this graph and I turn it sideways. Now, the 3 is positive, so that means it's going to be opening to the right. So it's going to look like this. And this 3 is going to make my parabola be skinnier. It's going to be a skinnier one than the parent graph. And so if I were to graph this vertically, it would look like this. Don't do this because I'm going to erase this, but I would be going over 1, up 3. It would look like that. And then 2, 4 would turn into a 2, 12 and would be way off my graph up here somewhere. All right. What I'm doing is I'm going to make that graph, but I'm going to go sideways with it. So I still think of it like that, but now I'm turning my head sideways, or I'm turning my graph sideways, and it's going to be 1, 3 this way. 1, 3 like that. It's going to be a 1, 12, which actually falls right off of the graph. So it's going to have that same shape, only it's sideways. Looks like that. Okay, so that's going to be your graph of your parabola, sideways. But to figure out your focus and your directrix, I'm going to kind of zoom in on this space right here. Because I know, and when I say zoom in, I'm going to rewrite it over here. It's going to be really big because I know the focus has to be on the inside and the directrix has to be out here on the outside. And I know that that distance and that distance are the same. And we call that distance P. So they want to know actually what is this ordered pair. That's what we're looking for, the coordinates of the focus. So I've got to figure out this distance because I know where the vertex is right now. I have that plotted, but I need to know what P is so I can figure out where to plot this. Now, this is a little trickier because you really get a lot of fractions when you're doing this. So they're not really pretty numbers, so don't freak out. Remember that we have a relationship and we can use either one of these relationships. We can say A is equal to 1 over 4P, or we can say P is equal to 1 over 4A. Since I already know that A is 3, and that's coming from right here, since A is 3, I feel like it'd be really easy to just put a 3 right here, and 4 times 3 is 12. So P is equal to 1/12. So I'm going to go ahead and erase this because I didn't need that version. And so this is going to be P equals 1 over, and I'm going to just do this for the sake of your notes. We, of course, wouldn't do this later. We can do that in our head. But that's a 1/12. Okay, so this distance right here is 1/12. You can see why I kind of zoomed in on this space. Because I have to figure out then, if this is the vertex right here, notice it's right here, I have to go this way a 12th. I have to go to the right a 12th of a unit. And I have to go left a 12th of a unit to get to this directrix. Okay, I'm actually going to go left first. I'm going to do our directrix first. So our directrix, right now, you're at -1, but then you got to go an extra 12th of a unit. So I'm going to be at -1 and a 12th. Don't try to turn that into an improper fraction. We leave it 1 and 1/12. It's -1 and 1/12. But it's going to be a line. It's going to be this vertical line right here, really, really close to your vertex. And since that's a vertical line, the directrix is an x equals -1 and 1/12. Okay, this is going to be a little testament to how good you are with fractions here. So think with me here. If this is currently at, well, it's at -1. I'm really only concerned about the x value there. I know that for the focus, it's going to be right in here, squeezing it in right there. I know it's going to be up 2. Can you tell me what would be the x value of it? If this is at -1 and I went this way a 12th off of -1, where would you be? Negative 11/12. All right. That's where it's talking about, got to know your fractions for this kind of thing. All right, and now we've got everything figured out. We have it graphed, we have all the info figured out, and we've got kind of a nice, good example of a sideways parabola. Now, I am not doing tons of examples here in our notes because I'm trying to have work time. I get it that you're watching this, which means you're probably not in class, but I did not. We had a lot of work time in class to practice this. So I'm doing like one of each scenario, and I'm going slow through it. Okay, here's another scenario. This should look familiar. We have done this before. It says write the equation of the parabola with the given info. Okay, notice it's a sideways parabola. So to me, I automatically know this is going to be an x equals. I'll go ahead and get started writing that maybe. It's going to be an x equals. There's going to be an a value here. Then you're going to have in parentheses y, and really it's a k in this spot now. And then you got your plus h on the outside. Now, I already know the vertex, so they were nice enough to give me the vertex. So I'm going to go ahead and fill in the h and the k. So this is going to be an x equals a. Now, remember, the k is the, where did you go vertically? It's with the y. So that's the 3 right here. That's what I did vertically. So since I went up 3, this is going to be a y minus 3 squared. The h is going to be my horizontal movement. And so my h is a -2. So I put -2 right here. What I don't know is the a value. So I'm betting most of you maybe remember that all you have to do is you take this ordered pair right here, you plug it in for your x and your y, and you go solve this equation for a. And you can do that, and I am going to do it in just a second. But since we kind of have already done that earlier in the year, I'm going to kind of challenge you a little bit and see if you could maybe do this even in your head, if this maybe makes sense. All right, now you got to turn your head sideways. Turn your head sideways. I'm turning it to the left, so what I'm looking at over and up. I know that feels backwards, but I'm looking at it sideways to plot this point. So if I were to go over 1, up 1, over 2, up 4, over 3, up 9, kind of like that, looking at it sideways. Let's look at what we did here. So I was at -2 here, and I was up 3. So if I was up 3 here, and this one I'm up 6. So I was up 3, and now I'm up 6. How far did I just go there from 3 to 6? I went 3 units. And if I went 3, I'm supposed to go 9, right? Because you're squaring it, 3, 9. But I didn't go 9. Look at how far I went. I was at a -2, and I went to a -5. How far did I go? I only went 3, didn't I? I went 3 units, and I was supposed to go 9 units. So what portion of the way did we go? We went 1/3 of the way. But notice we are opening up to the left, so it's going to be a negative. So I think I'm going to go through this, and I'm going to figure it out algebraically, but I think my a is going to be -1/3. Let's go ahead and fill it in so you have some way to do this when you forget that little trick. All right, so here we go. I'm going to put this ordered pair in for my x and my y. So -5 is equal to a, 6 minus 3 squared. Order of operations here. Be careful. Be sure you square this before you do any subtraction or anything. I'm sorry. I take that back. Make sure you subtract this before you do any squaring. So I'm going to subtract here. That's going to be 3 squared. That's a 9 times this a. So this is a 9a, and I'm going to go ahead and move the 2 to that side. So if I add 2 to that side, it's going to be -3 equals 9a. Divide by 9, there's my -1/3 that I thought I was going to have. Okay, so now I'm going to go back, finish up. Let's write the equation. X equals -1/3. Y minus 3 squared minus 2. That's the equation of our sideways parabola. Now, I will say this, probably I would want to see some sort of work. I would love it if you can think through this mentally like I just did over here. I'm going to say usually about 1/3 of the people can kind of figure that out mentally without having to do this. but I would like to know that you did that and didn't just sneak a peek at your neighbors. So if you would just sketch me what you're doing, even if it's like, just show me this, I went 3 and 3 or something like that. Show me a little sketch of what was going through your head. All right, now that writing equation problem that we just did is one that you have done before. Now let's try writing the equation using some of this new information that we have with the focus and directrix relationships. All right, on number 8 here, it says write the equation of the parabola with the given info. All right, so I've got a vertex at 5, 3, giving us a little graph so we can plot this out and get a good look at it. There's the vertex. The directrix is a line, remember, at x equals 2. It's an x equals, so that means it's vertical. So vertical line, we do the directrix as a solid line. If we're doing axis of symmetry, that would be a dashed line, but directrix is solid. All right, now if this is going to be my vertex here, and that's my directrix, I want you to take a minute and see if you can think about which direction is this parabola going to open. All right, hopefully you're thinking, oh, that's going to have to open to the right, like this. It's going to have to be a sideways, because remember the directrix will never touch your parabola. So it's on the outside of that cup of that parabola. So this is what it's going to look like. So if I'm going to write the equation, then I know this is going to be an x equals because it's opening a sideways. So think about this, x equals, and then there's going to be some a value, and then you're going to have a y minus k squared plus h. Now they gave us the vertex, so I already know what k and h are. It's going to look like this. Now remember, this is backwards. This is the k is with the y value. The y value is a 3, so it's a y minus 3 squared. And then the x value is the 5, so it's a plus 5. So what I have to work on is this a value. That's what I have to figure out. Now, the a value tells you how wide it's going to be. And I just sketched, the graph here is strictly just for me to get a sketch going. It's not accurate necessarily as far as how wide that is. But what I do know is that this distance between the vertex and the directrix is 3 units. I can see that. That means the focus over here would be 3 units also. But what I really care about, not so much what the coordinates of the focus are, but that distance between the vertex and the focus is 3 units. Because that, remember, is your p-value. And you have 2 options. You can do p is equal to 1 over 4a, or a is equal to 1 over 4p. And since we know what p is equal to 3 in this case, I feel like it would be easier to use this bottom version. To figure out the a, it'd be 1 over 4 times 3. So the a is 1/12. And so I'm going to plug that in, and here's your equation. X equals 1/12. Y minus 3 squared plus 5. So a 1/12, that really would be a very wide parabola. Okay, let's try it one more time. I'm just going to give you different information, but see if you can figure this out. We've got the directrix is y equals 3. Y equals is horizontal at 3, so there's my directrix. I have a focus at 4, 2, right there. All right, can you, with that, envision what your parabola is going to look like? All right. Remember, I'm going to use this as an example. Remember, here's your vertex. Going one way is the directrix, the other way is the focus. The vertex falls smack dab in the middle of the focus and the directrix. And I know the focus and the directrix. They're right here. And the vertex falls smack dab in the middle of the two, which is not real easy to draw, but it's going to be right in between there. Can you tell me what that coordinate, what those coordinates would be for your vertex? All right, you're still over 4. The focus was up 2. I'm going to have to be up 2.5 for the vertex. Okay, so have you decided yet if it opens up, down, left, or right? Okay, the focus is always inside the cup of the parabola. It's going to go and do something like that. Okay, so this is a downward parabola. We know what the vertex is, but since it's that standard up and down, it's actually going to be a y equals. So it's a y equals. There's going to be some a value. We usually work on that last. And then you have x minus, and this is your x value, so that's the 4 squared plus, and I'll let us go ahead and leave that as a 2.5 right there. So now what we got to do is we got to figure out the a value. And the a has to do with the p, right? The p, in this case, the distance between the vertex and the focus is 1/2. So if p is 1/2, what would a have to equal? Well, a is equal to 1 over 4p. What is 4 times 1/2? 2. So this is going to be 1 over 2. So not only is p 1/2, but a is 1/2. This is the one scenario where they are the same as one another, as that 1/2 spot. Okay, so I think I've got my equation. It's going to be a y equals, the a value is a 1/2, and I got my x minus 4 squared plus 2.5. Whoops, no, 2.5. Okay, all right, that's it. All right, go get it. Hopefully this will all make sense for you. Good luck. Bye.